Alright guys, time for our first lesson in Physics 101 with Camden, my boy Jake, who's we're going to interview today, and Jacob on camera. We're actually going to teach Jake today about Isaac Newton and what he did, and discoveries, and his three laws of motion. So Jake, I want to ask you, what do you know about Isaac Newton?
I don't know anything about Isaac Newton.
Isaac Newton? Okay, well Isaac Newton was a famous scientist back in the history. He was his most notable works are his work on gravity and his works on three laws of motion, which kind of founded modern day physics. And then his development of calculus is what helped us discover other things, kind of like the light spectrum. So now I want to ask you, going further into this, what do you know about Newton's three laws of motion?
Nothing.
Nothing?
I don't know.
Well, they're pretty simple to understand. So Newton came up with these three laws of motion, and the first one basically reads that an object will continue in straight line motion unless acted on by an outside force. So what that means is an object is going to continue on its path unless something in the outside environment proceeds to act on it with any kind of force to disrupt that motion. Kind of makes sense. His second law basically reads that the sum of all forces on an object are going to equal that object's mass times its acceleration. So what that means is all the forces that are acting on the object, right, equal how much mass it has and the acceleration at how fast it's moving. And then this third law finally states that every action has an equal and opposite reaction. So, it kind of means like all forces come in pairs. If one force acts on an object, then there will be another force to reciprocate the opposite force. And so now we can go on and do a little demos. We'll start with the first law. So here's a pretty good representation of Newton's first law. We have a ball rolling on a street, and the velocity is pointing towards the end of the street, going down here. And this object is going to continue with no outside forces on the environment. It's going to continue going and rolling down this street for infinity, basically. And so we can see that doing a demo, because I'll show you. We've got an empty water bottle. So if Newton's first law proposes that an object will continue in straight line motion unless acted on by an outside force, this bottle should just go straight down, right? Okay. All right. And so now I'm going to show you, the kind of it being acted on by an outside force. So we go like this. It doesn't proceed to go in a straight line. So we'll do that one more time. For the people who didn't get to see that, for the boys in the back here representing, we got the bottle, and once acted on by an outside force, it doesn't continue in the straight line motion.
Can I participate?
So now we'll move on to our second law. And we have a diagram here. And basically, we kind of like to summarize Newton's second law in just about an equation. So this sigma F on the left, it means the net forces. So that means you're summing all the forces on an object. And that is equivalent to the object's mass. The object's mass times its acceleration. So when we look at the picture, we have two different diagrams represented by the same force. We've got, a person getting a force acted on it by with a bigger mass. And we have another person getting acted on by the same force with a smaller mass. So the difference between here is that because the object's mass and its acceleration are directly inversely proportional, the person with the larger mass is going to have a smaller acceleration because, as you increase mass, acceleration is going to decrease. And the person with the smaller mass is going to have a bigger acceleration because as you decrease mass, you're going to have larger acceleration. Finally, moving on to our third law. Like I said, kind of summarizing it, every action has an equal and opposite reaction. So we have a spaceship, and the spaceship is getting thrusted up in the air by gasoline and all the fuel that's burning and the propulsion force. And so as all the fuel is being burned and creating that propulsion force, that is our action. It is producing it downward in the opposite direction, and it's actually moving our spaceship upward as an equal and opposite reaction. So we can do a pretty easy, kind of demo. If you want, I want you to take your hands and I want you to just press on the desk.
Okay.
Press on the desk. So now let me ask you a question. Why aren't you moving through the desk right now?
Because it's solid.
Because it's solid? Well, actually what's happening here is as you push on the desk, you are applying a force to the desk. But as you are acting with a force, the desk is reacting with an opposite force, preventing you from traveling through the desk. So as you apply a force, the desk is reciprocating a normal force in the opposite direction, preventing you from going through that desk.
Wow.
So there you go. Now you learned about Newton's 3 laws of motion.